All right, BCA, Intro to Computers. We are working on security. I reviewed a couple things first. We talked about this whole idea of a logical diagram and then the actual physical connection. They refer to that in the world of technology as topologies. What does it look like? This is a logical diagram. We've got that big cloud of the internet. It's not exactly how that all hooks together, but we can kind of show how it works. We can show that in somebody's house they have that little router and that you can connect to. It goes through their modem to their ISP. Here I have Mediacom. We can talk about how we can store stuff out on Google in their data center. Some level of trust, storing stuff out in the cloud. The same thing, the data stored at your bank. And we also talked about the issues of a modem and a PC connected directly to that because the public address going straight to the PC. So this is all a logical diagram. We showed a little bit on this side of NIACC here. A physical diagram, that blue wire comes from the computer. You can barely see it back in there, but it comes up through that hole. So the blue wire comes from the computer, goes into that orange port. Then we have those cables right there, wrapped in that white binding stuff, and then they go underneath the table, down along the floor, up that white conduit on the side over there, comes across the ceiling, comes down the gray one, comes into the back of the patch panel, and I could give you a little bit of a view of that. Yeah, those cables coming in there. Anyway, so then these orange ports here on this side, they all connect to the orange ports out in the room. So this would be the physical connection, and all those blue cables go up here to the switch. And then from the switch, the green cable, right there, with the little green lights flashing, that cable runs over up to here, and that port then runs out of this room to another room and connects to another patch panel and so forth. So that's physically how it all connects. And then over here, I just show the PC connected to the switch, and then the switch, that green cable from switch connected, eventually connects to this device, here to our ISP, which the ICN gets us out to the internet, or gets us to other servers here on campus. Then the next thing we needed to clarify was that private addresses and public addresses. And so we reviewed that again. Internally we have all these private IP addresses. And it doesn't mean that people can't see them. It's just a term we use for addresses that we use on the inside of our network. And then they're translated or converted to a public address that allows us to go out to the internet. Same kind of thing can happen at other places. It comes in off the public and is converted to a private address used at the internal network. It happens right here. Happens right in your router. You probably have a 192.168 something something in your house, but when it goes out to the internet, like in the project, when you're supposed to find what address, what public address are you using, and you look up what's my IP, it'll give you an address that you got from your provider, whoever that might be. Alright, so we talked about topologies, physical and logical. We talked a little bit about voice over IP, and then we got into talking about data. Data, you know, there's all kinds of data at banks. There's data stored on personal computers. There's data stored, in fact, all these places connected into the internet. We have data stored here at NIACC. Okay? There's just lots of data. Now, we have to be concerned about the security of data in terms of where it's stored, or when we're moving it from one location to another, or while it's actually being processed in a computer. What do we have to be concerned about? Well, we have to make the data available. You know, if you don't have to make it available, you can make it pretty secured. We're worried about the integrity of the data. Is the data correct? The data hasn't been changed or adjusted. The data is correct. Somebody hasn't been able to go in and change or adjust the data from what it's supposed to be. And then confidentiality, that has to do with who can see what data. We want to make it available to the people who need to see it, and the people who should not see it, we need to secure it from them. How do we do that? We have products and devices. We'll talk more about those later, but a simple example, here at the college we have a device called a firewall that monitors information coming in and out of the internal network. You have products like you can run a piece of software on your computer, firewall software, you can run virus software, all kinds of products to help us secure things. People have to put the products in place, and then people have to be trustworthy. People can't be giving out passwords. People can't be tricked using social engineering to go to sites they shouldn't go to, and people collect information from people. Some do it maliciously, but others, it's pure accident. They just don't know better. We have procedures, certain things we follow. How long should we keep emails? Where data should be stored? When to back up? We have all kinds of procedures we perform. What guides those procedures are policies and guidelines. We have a written policy that tells us what we need to do, and then we have the actual procedure to get it done. Some businesses have their employees delete their email after 2 weeks. Okay? Now, the difference between a policy and a guideline, a policy would have consequences, anything from being disciplined for doing something to maybe even being let go from a company for doing something inappropriate. Guidelines are things we should do, things we should follow, but there may not be a specific consequence for not following it exactly. Gives yourself a little leeway. Okay, so these were the notes for today, and the students also use the iPads, and they experimented with Pages to see another way to use a word processor, and then that's it.